I times the multiplier, whatever. Then, so that happened. So then what's our next step, you think? So this is what we've been talking about before we get the multiplier. Maybe the multiplier is 4 there, who knows? What's the next step, everybody, on this diagram? If we're going to take another step, y goes up. What changes in our diagram? Sorry, Erica? Money demand, everybody. Does the supply of money change? No, no, no. The supply of money changes if the reserve ratio changes. That's not happening. Currency in circulation changes. We didn't say that was so. And the Bank of Canada does something. That's not happening. And that's independent. It can happen. And I'm going to ask you about it in a minute. But it's not happening right now. So the demand for money goes up. We'll just do it like this. Now let's designate this as the demand for money at YS, right? So demand for money goes up. The economy is expanding. The public wants more money. There's not enough money. There's no new money. So they bid up the interest rate to here. Call it RS. You'll see there's a reason for doing that later. And then, of course, the new interest rate causes, assuming there's no change in MEI, and we'll always assume that except if we're making a multiple choice, down like this. Investment follows. Now, everybody just note, call this IS if you want. On this diagram here, this dimension, investment is of course a lot smaller than real Y, maybe a fifth of it or whatever, something like that. So don't think of this distance here as being related. So what does that do now? What happens next? Investment falls. What happens next? AE shifts down, right? So it turns out, you might say, well, is investment going to be greater than or less than G? Well, it's going to be less than, because otherwise the thing wouldn't work. But how much less, we don't really know. In fact, it could be almost, we drop down almost the whole amount. Usually we won't do it that way. We'll put it somewhere like that, right? And this change here is minus I, like that. This is the investment flow right there, right? Minus, I should say DI. Although the fall, that's the fall, right? So then that's going to give us a new equilibrium right in the middle here, say. Doesn't have to be in the middle, but we'll just stick it there. Okay? And that, now what am I going to call that thing? Hang on a second. I'm going to call this, I'll do it in red. This is AE, call this now 1, which is for GS and IS. Notice it's different than the original, that was IO. Okay, so, and I'll just do this. So you realize that's what that is. Okay, stick it up there. And then that gives us this equilibrium. Now notice, the one thing that's really important to notice here is we don't get the full multiplier. We don't get the full multiplier. So it turns out this is called crowding out. Crowding out. I'll just put this here. Sorry, here. Crowding out. All right. Now this, so, all right. Basically you had Keynesianism appearing in the 1940s and 1950s, given the success of, the effect of World War I, government spending on the Great Depression, eliminating it. The economies of at least the West were growing really rapidly. But there was people who were attacking, and obviously got by governments to control economies. That's so non-classical economics or neoclassical. So there's various chipping away at the idea, and one of them was this. The argument that government spending caused this big multiplier. I remember reading when I was young, you guys, it wouldn't be, but it would be true for you people, but I can remember where I grew up. You know, even like when I was younger than you, even then, who knew nothing. Recognizing every time there was something built, the local shopping mall. Should we build this mall? Yeah, because it's going to have a big multiplier. It's good for the economy. High rises. You know, Jamestown, St. Jamestown, that place is just a complete disgrace as far as I'm concerned, all those high rises. You know, not good for city living. No. This is great in the U.S. Tear down slums and stuff like that and build high rises. Because not only do you get rid of the slums, it has a stimulative effect and everybody gets a job. I mean, in the 50s and the 60s, this is a big thing, like multiplier. But people said, then people started getting at it and saying, hey, wait a minute. Your multiplier is not going to be 4. What's going to happen is, when you increase government spending, you're going to increase, the economy is going to grow, it's going to push up the interest rate. The higher interest rate is going to crowd out private investment. So instead of, I could say, we're going to spend $50 million, the government's going to spend $50 million and cause a $200 million increase in GDP. Well, it turns out the $50 million in government spending is going to push up the interest rate and crowd out $25 million in private investment. So you're not going to get $200 million more, you're only going to get $100 million more, because you're only getting a net increase of 25. And you crowded out private investment. And we don't want the government taking over the economy. This is not good. So by the way, in the 1990s, amongst other things, if you look back, Paul Martin, Chrétien, finance minister, and this was the mantra of the 90s, reduce government spending. Of course, it's the mantra of the Republicans too. Reduce government spending because it'll lower the interest rate, and lowering the interest rate will stimulate private investment. Right? The government's choking private investment. Same idea in the U.S. Crowding out. All right. Now, let's just look at this. Supposing I said to you, just be aware of this, I said we don't want to have any crowding out. If we want to get the total multiplier effect here, how can we prevent crowding out? Tell me. Think about it. I want to prevent crowding out. I want to get the full multiplier we had before. How can we do that? Just by the way, how can we do that? I don't want crowding out. Notice the demand for money went up and the interest rate went up. I don't want the interest rate to go up. I want government spending to go up, but I don't want the interest rate to go up. What am I going to do? You're a government, yeah, go ahead. Sorry? Very good. Everybody, increase the money supply. That would be a good thing to do. Or what would be a thing to do, right? You could do that. If you increase, I don't have it in my notes, and you may not see that in this exam because that's a little bit more sophisticated, but all that's happening is you could increase the money supply and get the full multiplier and have no crowding out. You could use fiscal policy and monetary policy in conjunction to get a big change. Everybody? So just be aware of this. So this is the type of policy thing that you might be doing. Okay, now. So I'm just pointing out to you crowding out is a real issue. Now, if you look back at my notes for increase in the interest rate, like money supply, or decrease in money supply causing stimulation of investment, I don't have any crowding out there. But by the way, it would be crowding out. And this isn't the final story either, because leaving this aside, for the moment, leave this aside, notice this would cause a new demand for money, somewhere in here, which would cause slightly more investment back here. We would go round and round until we got to some iteration in the middle. But we kind of go back and forth, right? Although it wouldn't necessarily behave that way. As the government increases spending, the demand for money is going up, the interest rate is going up, and you get a kind of equilibrium rather than jerking forward and back. But this is more sophistication we're needing to go into. Okay, what we need to go into, though, is this kind of a calculation. Right here. All right, notice what I got. I want you to write this down. This is money demand. This is money supply. This is aggregate expenditure. This is the marginal efficiency of investment. Now we're going to do a little thinking for you people. This is an aside. I'm just going to point something out to you. It's in my notes elsewhere. How many variables have we got? How many variables? We have MD, MS, R, AE, IO, marginal efficiency of investment. 1, 2, 3, 4, 5, 6 variables. All right? How many equations have we got? MD, MS, AE, MEI. Okay. How many equations do we need to solve to get a unique solution? How many equations do we need? If we have 6 variables in a linear system, how many equations? Erica? 6. We actually have 6. We have this equation, money equilibrium equation, MD equals MS. We have that equation. And we have another equilibrium equation. What is it, everybody? Oh, I better put another variable in there. We have Y. Didn't get that variable. We have AE equals Y. So I get 7 there. Let me see here now. 1, 2, 3, and that's 9. Very good. Oh, and you know what our other equation is? Wait a minute. Let's see. Oh, let me do this. This is MEI like that, right? But it's also, I'll do it in a way that's a little bit more obvious. It is IO, right? IO, like that. That's what that thing is there. So those are not separate variables. That one and that one are the same. Everybody? Okay? Good. Now you will notice that we have 6 variables and 6 equations. There is a unique solution. And the way you find the unique solution is this. If you plugged in, you did MD equals MS, R was a function of Y, then you plug that into this, R, in here, you'd have IO was a function of Y, and then if you plug that IO in here, you'd have AE was a function of IO, which is a function of Y, which is a function of Y, and then you'd have at equilibrium, Y is that. I don't need to give you Y. You can solve for Y. I'm just telling you that. You can solve for Y. But in an exam, I'm not going to ask you to do that because it's too cumbersome. If you make a mistake getting all the equations lined up, it'll be hopelessly time consuming. I've done it myself. It can be kind of awkward. So basically, I'm going to give you, I'm just telling you, you have enough equations to solve this. You don't need what I'm going to give you. I'm going to give you this. Y is 1200 to make life easy for you. And on this exam, that's how we'll do it. Now we want equilibrium R. Let's have it. And of course, you know, MD equals MS implies R equals, well, we do it this way. We're going to solve for R. 90, let's put it over here for the moment, equals 0.1 times 1200 minus 500R, right? Which implies R, I'm just flicking around here, everybody notice the reasons you'll see later. R equals 0.1, I'm still sticking Y back in there for reasons you'll see in a minute, minus 500R divided by sorry, minus, excuse me, minus 90. Actually, I put here minus MS. Equal, divided by 500 equals, in our case, I'll do it like this. (0.1 times 1200 minus 90 divided by 500 equals what? 6%. 0.06. Answer. 6%. Okay, next. What's equilibrium? IO. MEI. Remember, this isn't all investment, it's just the investment's a function of the interest rate. The rest of the investment you've got stuck in there will reduce as a form of income. That one. What is IO? This doesn't take a week to figure this out, surely. Oh, wait a minute. Maybe this shouldn't be 10, it should be 100, sorry. That's 100 R. IO equals 26 minus 100 times 0.06. And our number is 20. Good. Now then, what is AE? It is equal to 280 plus 20 plus 0.75y. And at equilibrium, y will then be equal to, when you play around with this thing, or standard thing, 280 plus 20 divided by 1 minus 0.75, which is equal to 1200. Okay? Is the economy in equilibrium? Yes or no? Is this economy in equilibrium? Yes or no? Cat, you look like you were on top of it here. No? Is it in equilibrium? Is the economy in equilibrium? Yeah, leads to it. Because why leads to it? Yeah, the AE that we started with is the AE at the end. That AE would give that money demand, would give that interest rate, would give that investment, would give that AE. We're in equilibrium. Okay, then, let's see what we got now. Things to play with. Let's try this out. Suppose we increase G by, let me just figure it out here. Let's see, by you need to increase G by we'll just increase G by okay, we'll increase G by 0.75. Ready? 0.75. Okay. Now, I'll put equivalent line. Okay. Now, where do you think we're going to go? We've got all these equations. Which equation are we going to begin with in this case? AE, everybody? AE, right? AE, look at your diagram. One of the things in this course I want you to do is you use your diagrams to illuminate your equations. You use your equations to illuminate your diagrams. Ultimately, when you go for a job interview and stuff like this, I'm telling you, You sit down with an investment bankers, and these guys are forgotten all this time. They're going to ask you questions. You might know the answer. Okay, just sit down and start drawing diagrams. Let me see now. They might say, what do you think is the effect of this and that? No, if you don't know, this is how you analyze, right? You work it out. It's a type of analytic technique. So, if you don't know what happens, you go back and you go, let me see now. What did I do with my diagram? Let's see, what did we do with our diagram? We went to our diagram, I don't know where I am, right here. Oh yeah, I shifted up AE, right? Okay, so, here we are. So, now then, we're going to do y equals, we're going to have AE, okay, let's do AE equals 2AE plus 0.75 plus our original IO, which is 20, plus 0.75y, which implies equilibrium y. Notice I just skipped to the chase here, is 280 plus 0.75 plus 20 divided by 1 minus 0.75y, which of course is going to be 303. Actually, it's going to be, 300.75 times what? What's the multiplier? What's the multiplier? It's staring you in the face. Come on, guys, what's the multiplier? Oh, hell. How did you do so well in that last exam if you have no clue and you can't think? How did this happen? Divine intervention. God came down and blessed you all with that exam. It must be. What is the multiplier here, people? What is the atomic spending multiplier? What else would it be? What is it? Huh? 4. Look at it. 4. In this course, and particularly the final, you've got to integrate things. I could do like I'm going to say. In a minute, I'm going to blow you guys totally out of the water with something that you should know. And in fact, in this exam, question number 3, I'm going to ask you this in about 50 different ways. Question number 4, I'm going to ask it again, and you're not going to remember. Right? You know all about the multiplier. If I talk to you just about the multiplier and the macro model, oh yeah, it's 4. We know it. Here, you didn't know it because you're not integrating your thinking. All right, times 4, which turns out to be, plus 0.75 times 4, 1,203. All right, everybody? Got it? Is that correct? Looks good. Okay, then, next. What is equilibrium R? What is equilibrium R? I might need this to be down. What is it? Come on, people. You can do better than this. Just apply your brains to it. Well, wait a minute. It's right here. Oh my goodness, there it is. Money demand equals money supply. It's just that it's not 1,200 anymore. It's 1,203, right? So plug it in right here like this. It turns out to be 0.1 times 1,203 minus 90. All that stuff is the same. Money supply hasn't changed. Divided by 500. What does that give us?
6.06%.
6.0, well, okay, we'll do it this way, sorry. 0.0606, which is equal to 6.06%. All right, this government spending pushed up equal, the interest rate by 0.06%, not huge. Let's see if it is in fact significant. All right, what is investment now? What is investment? What is this thing equal? Kyle, is that the first time you've dug out your calculator today? Good. That's good. Remember, I might be in the mind to bring down your marks a little bit in this next exam, so you better be sharp as turtles. We have to throw scare into you probably before the final, so you better be ready. You got to go in there frightened, I think. Fear is good. But actually, I'm not going to surprise you. I'm just going to come at you with this. Boom, 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 boom. So what is IO before I die of boredom? 1994. Right, times 0.006. 19 point. All right. Okay, here's my next question. People pay attention. Look at the board. What is crowding out? What is crowding out? Whatever it is. This can't be difficult, can it? Yes, Kyle.
0.06.
It's 0.06, right? Crowding out is the difference between the original investment and the new investment. So it's going to be, you can do it like it's the change in IO, which in this case would be 19.94 minus 20, which is minus 0.06 as an amount. Okay, good. What is equilibrium Y now? Now this turns out not to be equilibrium Y, it's just another iteration. Watch me. Again, Y equals AE equals, what do we got? We've got 280 plus 0.75 minus 0.06 plus 20. All divided, in this case it would be, I'll just jump to the chase. 1 minus 0.75. So what do we got? What is it? Well, this is not difficult, eh, guys? 280 plus 20, 300 plus 0.75, 300 plus 75 minus 0.06, 300.69 divided by, or times 4. Is that correct? So it should be 1,202.76. Nice. Now, again, all these things are conceptual. You can just see that just keep coming at you all day. What is the multiplier? Now, by the way, I say equilibrium Y. It's not equilibrium Y because this is going to cause a change in Y, which is going to cause a change in demand for money, a change in dress, and so on. But this will be good enough for us. It's not perfect equilibrium, but it'll be fine. What is the multiplier corrected for the interest effect? And remember, the multiplier, the A multiplier, is always equal to the change in Y, dy, put it like this, for change